Good morning, everybody. Welcome to another wonderful morning of Chem 1211 with your host, me, Dr. White. And to start off, I have a few public service announcements from me, the management, to you. And the first one is you should have all gotten my email, hopefully you read it, about amnesty for labs. You have until Sunday to hand in, most of you got your labs in, get your labs in for labs you haven't ended in. Remember, labs are 10 points and they're not that hard. So if you don't hand in a lab, you get 0 points. So please hand in labs. If you can't find a lab, email me. If you can't, if the link is no longer there to upload it in the assignment area of Blackboard, email me the lab and I'll grade it. As of last night, I think it was yesterday afternoon, I'm totally up to date as of yesterday for all labs you've handed in, and I've graded them and I've uploaded your grades to Blackboard. If you ever have a question why you have a certain score on a test or a lab, see me after lab or see me during my office hours. Don't forget tonight, 6 to 7:15, I'll be having my office hours. I am now offering free, well, actually paid for this class, so it's not truly free, but I'll set up a breakout room for any students who want to get together with each other without Dr. White, or you can also invite me in too. And that way, if you want to get together with some of your colleagues, you can. If you don't have Zoom, and just come to my office hour and I'll set it up. Now, another important, let me find where it is, public service announcement that I want to make is one of your colleagues had a computer meltdown and lost a lot of stuff on the hard drive, at least hopefully maybe your colleague can get it back. I would highly recommend, if you don't own one, get yourself a thumb drive or a flash drive. I've been using for years SanDisk. This one I've had for a couple of years is a 256 gig hard drive, flash drive. This is an older, smaller one, 64. The class grade book and all my files for lectures and everything are backed up on here. If you look over my shoulder, you can't see it. I have also external hard drives that I use for other stuff I do. Quick story, back when I was, Danny, your dog wants to join the club too, let him. But anyways, back when I worked for a company called Unicema back in the late 80s, wow, that's a while ago, because of my level in the company, I think every other week, we had a senior management team meeting, and Unicema was a division or a company owned by Unilever. Unilever, you may not know the name, but that's Bird's Eye, Green Giant, Lipton Tea, and a whole lot of other companies. And at that time was also Unicema. And each company within Unilever was treated as an independent company, and they had its own president, CFO, VP of manufacturing and technical. And I reported to VP of manufacturing technical, but because of my position, I also went to these meetings. And we just got a new CFO, Chief Financial Officer, who had actually been the CFO at Lipton, and he was asked to come over here to help us because we were somewhat of a newer company under Unilever. And at the first meeting, he asked, where are your backups? This is back years ago when you had magnetic tapes on a reel. And our president said, in our vault downstairs in the office. And the CFO, his name was Joel, said, no, that's not going to do it. What happens if this place burns down? And the president said, well, the vault's supposed to be fireproof. And the CFO said, yeah, right. You're going to trust all that information? It might. And he said, no, we're going to back it up, and we're going to have a backup offsite in a safety deposit box in a bank, monster ones they got. I never saw them, but it was described to me. So It pays to back up stuff. These are inexpensive. You can get a, I don't know if you need 256. I like big backup. I go overboard. These are about $35 a piece. You can get smaller ones at Staples, Amazon. I'm sure even Walmart sells them for a lot less. Back up your stuff. All right. With that in mind, it's time to do some chemistry. And I thought, let's do a little review, a little practice that will help you out. Uh, Next week, I believe, will be test 2. By Friday afternoon, I will post the points breakdown, how many pages, and what topics it will cover. I can tell you what topics. It'll cover electron shells and all that. I think it's chapter 6, 7, 8, 9, and 10, but don't quote me on that. Electron shells, valence electrons, uh, ions. It will also cover, am I off by a week? Maybe I am. You know something, I am. Well, I'll get it out anyways, and I'll cover the mole stuff we're talking about. We're almost done with that. Ooh, another uh, uh, announcement. Remember, this Thursday, if you have lab on Thursday, this Friday, if you have lab on Friday, I'll go through chapter 6 and chapter 7 problem set. Also, don't forget the lab that's due on Thursday or Friday, do it and hand it in. Actually, don't hand it in anymore, upload it. All right. And Biljana, I'll check. I think you're right. It's not next Wednesday. It's a week from 2 weeks from today. For all of you whose heart's beating real fast right now, hopefully that will slow it down. Uh-oh, awful Wednesday humor. All right, let's get to work. Justin, it's probably right. I was off by a week. That happens. So it's really the 24th or 2 weeks from today. All right, let's do some important stuff that you should know. But before that, oops, I got to open up a periodic table. All right, let's do the following. And the question is, how many moles KOH is 47.51 grams KOH? Now, let's do something real quick. One of the things you'll need are the atomic weights of potassium, of also oxygen and hydrogen. And let's take a look, and I'll help you out. For potassium, is 39.1. For oxygen, it's still 16.0. And hydrogen to 3 significant figures is 101. And you'll need that. How do you tell that? By the atomic weight underneath the element in the periodic table. And as I've mentioned, on test 2, 3, 4, and the final, it will say, please use all atomic weights to 3 significant figures. So with that, I can now help you out a little. And these are the atomic weights. And it's your turn. I'm going to start out the morning sharing. One other thing I'll share is 1 mole of a compound. This would be an important information. Test number 2 equals the molecular weight in grams of the compound. And the molecular weight in grams of a compound equals, and who has a question, I'll get to you in a second, is the sum of all atomic weights. Oh, somebody already did something. Thank you, Biljana. If you don't have your calculator, just set it up. Excuse me, this is one of the few shirts I still own that has a label back here, and it was scratching me. Bad label. Don't forget to use your good buddy, your good friend, unit analysis. For those who came in late, don't forget to read your email where I talked about lab amnesty program till Sunday. And for those of you who finished early, please be patient. I try and give everybody time to finish. Everybody finish. I'm in a good mood because yesterday I have in my entryway, kitchen, and dining room this beautiful parquet-like floor. That's, you got to be very careful when you wash it with special cleaning fluid, and when you put a coating, it's not really a wax because I've had it in this house. I've been here 22 years, and it was already in a couple of years, and it's looking beautiful. I waxed it last night. I really polymerized it, and it's looking beautiful. And this afternoon, I'll put on a second coat. See how little things make Dr. White happy. A beautiful shine on that floor does. This is one of the reasons I bought the house. I said, wow, this is pretty. I like it. Little I know how careful you have to be with it, but it's still pretty and I like it. And the votes are coming in. Who's going to win? All right, I'll give you another 15 seconds and we have to move on. And you can always come back and do this on your own if you haven't finished. Just don't look at the answer. Try it again. All right, let's get going. Question is, how many moles of KOH, potassium hydroxide, are 47.51 grams KOH, potassium hydroxide? So what I like to do What am I being asked to find? Moles KOH. What have I given? 47.51 grams of KOH. What do I also know? This, which will be an important information, test number 2, but I know 1 mole of a compound equals the molecular weight in grams of a compound, and the molecular weight in grams of a compound is the sum of all atomic weights, and I can find the atomic weights from the periodic table. So there's only one number I have to work with, and that's this. Don't forget to write the units down and the molecule you're dealing with. And if I can convert it to my answer, what units do I want my answer in? Well, we took the time, and that's moles KOH. And you know what's coming. It is, here it is. What time is it? It's time to use your good buddy, your good friend, unit analysis. Love it. And how do you use the analysis? Whatever you're trying to get to goes on top, the units. Whatever units you don't want in your answer goes underneath. And on top, I want moles KOH. Underneath, I want grams of KOH. Remember, anything divided by itself cancels out because it comes to number 1. So this cancels out. I'm left with the right units. Where do I get these numbers? 1 mole of a compound equals its molecular weight. What's the molecular weight? The sum of all atomic weights, which is 39.1, 16.0, 1.01. Add them up. You have 0. And that would be 56.01. Now, remember when you add, you have the same number of significant figures to the right of the decimal point as the number that has the fewest significant points to the right of the decimal point. This has 1, 1, 2. Smallest number is 1. So keep the 0, use that to round off, drop it. So here, this would be 56.0. And now I'm going to go to my calculator, which I don't have opened up, so I better do that quick.
Hey, Dr. White.
That's me.
Wouldn't it be 56.1?
Did I make a mistake? Let's find out. And the answer is yes. Oh no, I'm going home. Wait, I am home. Whoever brought that up, thank you. Thank you very much. Now, important thing, if you had showed all your work and you had written the wrong number like I did, because I made a math there, if this were a 5-point or 6-point problem, I would only take off 1 point. If you just show your answer and none of the work, I'd take off all the points. So it always pays to show your work. Now, I can go to my calculator. I put in 47.51 divided by 56.1. Make it larger so you don't have to hurt your eyes. I don't want to do that. And how do we do this? One number was 4 significant, the other was 3. We're multiplying, dividing, in this case dividing. Therefore, the lowest number that you're multiplying, dividing is how many, the number that has the lowest significant figures. What you're multiplying, dividing is how many significant figures your answer should be. Keep the 4, keep the 8, keep the 4, keep the 6. Use the 8 to round off. That's 4, 5 or higher. Drop that 8, that 8, that 8. Make the 6 a 7. So that would be 0.847 moles. For those in scientific notation, which is perfectly correct, this would be your answer. So either one, that's the answer. And that's how you do it. This is how you go from moles to grams. We've covered it. Let's do another one. And the question is, how many moles HCl, hydrochloric acid, are 145 grams of HCl, something you will need. So I'm going to provide to you atomic weights of hydrogen and chlorine. How do you find those? Because you'll need them. You go to your friendly neighborhood periodic table, and Spider-Man, no. But anyways, and hydrogen, the 3 significant figures, 101. Come over here, chlorine. I'm going to let you round off 35.453, the 3 significant figures. I'll give you 5 seconds. 1, 2, slow clock today. 3, 4, 5, time's up. And this would be 35.5, the 3 significant figures. And now you can do the problem. I'm going to make you work today. Got my whip out. By the way, if anybody knows a good place to get a good 10-foot bullwhip with a swivel base, mine died a while ago, and I'm looking to replace it. Dr. Whiteson's unusual weapons. I'm an expert with a bullwhip, a boomerang, and nunchucks, among other things. Oh, by the one of the other things is tactical knives. So, plus, more dangerously, I'm an organic chemist who knows chemical warfare. Now you really should be shaking your boots. Well, Gabriella, would you rather be chuckling on my nunchucks or about my nunchucks, or feeling, oh, is this boring? Don't answer that question. I know the answer already. And by the way, I'm serious. Anybody knows I gotta start looking for a new bullwhip. I haven't cracked one in a while. I used to have years ago a 16-foot bowl. Oh, is that fun to crack? Dangerous, but fun. I gotta cut this out of the video. No, I won't. Hey, Justin, that's a great suggestion. I'll have to do that. I personally have bought stuff on eBay and AliExpress, but not Etsy. I'll have to look into that. Thank you. All right. I think everybody's done. Let's do this. All right. What are we being asked to find? How many moles hydrochloric acid, HCl? What are we given? 145.6 grams of HCl. How do we proceed? Use your good buddy, your good friend, unit analysis. And this is the only number we have to work with. And I want to get to what units my answer. You look up here because it took the time to figure it out, and that's moles of HCl. And now, if we look at this, we use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of goes underneath. And where do we get those numbers? I did the same type of problem again. Dr. White messed up. I'll have to do another one for you. We come up here and we look at 1 mole of a compound equals the molecular weight in grams of a compound, and the molecular weight in grams equal the sum of all atomic weights. Here we have the atomic weights, and if I add it up, but first change my color pen to the right color, we get 36.51. 2 past the decimal, 1, keep the 5, drop the 1. So one mole is 36.5 grams HCl. Notice grams of HCl divided by grams of HCl cancel out because anything divided by itself becomes the number 1. And now I'm ready to go to my calculator. And notice I'm dividing 4 significant by 3. Dr. White's in his 3 significant whole again, and round that off to 3 significant figures. Time's up. Keep the 3, keep the 9, keep the 8. Use this 9 to round off. It's 5 or higher. Drop that in the numbers afterward. Increase the 1 by 1, so you get 3.99. And that's how you do it. All right, let's move on. Whoa, talk about a run on. I'm going to let you try this first, but remember the coefficients of a balanced chemical equation give you the molar ratios. And what this tells you is 2 moles of hydrogen will react with 1 mole of oxygen when there's no coefficient. The number is 1 to make 2 moles of water. So why don't you try that out and then I'll do it. All right, I think everybody's just about done. But before I do this problem, let me just give you a little public service announcement, or I wouldn't call it an announcement, just a little FYI. One of the things with thumb drives, is you lose them or how do you? One, you notice I got a lanyard on it that you can buy. And then to protect it, I have a pill container, no longer using pills, and it fits right in. This way I can protect it when I throw it in my bag or in my pocket or whatever. Let's get back to work. All right, question is what? How many moles O2 oxygen gas are needed to make 4.666 moles of water, H2O? So what do I do? Well, I only have one number to work with, and that's this number. And now, what units do I want to get to? Moles of O2. And it's time to use your good buddy, your good friend, unit analysis. And that tells me whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And if I write those numbers or the units in, I have this. And the question is, where do I get these numbers? Well, you look at the balanced chemical equation, and this tells you for every 1 mole of oxygen, how many moles of water are made? 2. Again, for every 1 mole of oxygen, when there's no number there, it's the number 1. For every 1 mole of oxygen, I make 2 moles of water. So that's where I get these. These are exact numbers. They do not play a role in the calculation. So if you notice in this number, it's the only one that plays a role, and that's 4 significant figures. Therefore, my answer should be 4 significant figures. So if I come over to my calculator now, oh, before I do my calculator, I forgot to do something. Do my units cancel out properly? Moles of water divided by moles of water, anything divided by itself cancels out, becomes the number 1. This cancels out, I'm left with moles of oxygen. I set it up right. And here's the answer. And the 4 significant, wow, this doesn't happen often. Well, it does sometimes for Dr. White. Pick a number out of air, and the 4 significant figures would be 3.833. All right, now what we've done, let's put it all together. I balance this wrong because let's try something. Nope, I didn't balance it wrong. I've got it right. Once in a while, you look at something and it doesn't look right. Actually, I did get it wrong. Now I see where I made my mistake. All right, let's see, it's 4 hydrogen, 2 And sorry about the delay. All right, for this following equation, question is, how many grams of water are needed to make 145.6 grams of NaOH? This one I'll do. And what are we trying to find? Grams water. What are we given? 145.6 grams of NaOH, and we're given the now balanced chemical equation. And how do you do that? You need 3 steps. And if you look at important information, which I will now look at and open up for you, you'll see an important information, mass calculations for reactions. Step 1, convert the mass of A, whatever you're given in grams, to moles of that compound. Step 2, the moles of that compound you now have, you convert to moles of what you want your answer, the compound. And finally, you now have moles of the compound you're trying to get the answer for, and you convert that to grams. And let's get started. First of all, I'm going to need some atomic weights. Hydrogen is 1.01, oxygen is 16.0, sodium is 23.0. And step 1, what do we have the weight of? Sodium hydroxide. I want to go grams of A, in this case, that's sodium hydroxide, to moles of A, sodium hydroxide. So I have 145.6 grams of sodium hydroxide, NaOH. I want to convert it to moles of NaOH, and I'll use my good buddy, my good friend, unit analysis. Whatever I want to get to goes on top of the ratio. Whatever I want to get rid of goes underneath. Where do I get these numbers? 1 mole of a compound equals its molecular weight in grams. The molecular weight of sodium hydroxide is 40.01, but that rounds off to 40.0. And this is what I'll do. I'll take that number, 145.6, and divide it by 40.0. Remember, 4 is significant. The 1 is an exact number. 3, my answer should be 3. Oh no, he's in his 3 significant rut again. I am. And so I'll come over here. And this is the number I get. Wow, I'm on a winning streak. And if I round that off to three significant figures, that'd be 3.64. And don't forget, you can round off at the end or round off at each step. I'm a each step person, so, but you can round off and I calculate the answers both ways. But me personally, I'm a each step person. Now, we need step number 2, which is moles of A. In this case, we just calculated A, sodium hydroxide, to moles of our answer, which in this case is water. And therefore, I have 3.64 moles of sodium hydroxide. I want to go to moles of water. And if I look at the clock, we're going to go a couple minutes later than normal. You'll still get your 5-minute break. Dr. White won't cheat you out of that. And now we'll use unit analysis, our good buddy, our good friend. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And where do we get a ratio of moles of water to moles of sodium hydroxide? I see a question. Marissa asked a very good question. Let me take a look. The question is, wouldn't it be 4 significant figures? Notice we're doing a division and a multiplication. Whenever you multiply and divide, your answer has the same number of significant figures as the number that has the fewest significant figures. 145.6 is 3 significant figures. 40.0 is 3 significant. This is 4, this is 3. Lower number is 3. Therefore, our answer has 3. That's a good question, because now you won't get it wrong on the test. But back to this, where do we find moles of water ratio to moles of sodium hydroxide? You come up to your balanced chemical equation. And remember, the coefficients tell you the ratio moles of each compound. This tells me 2 moles of sodium react with 2 moles of water to make 2 moles of sodium hydroxide and 1 mole of hydrogen. So what's the ratio? 2 moles of water per 2 moles of sodium hydroxide. And therefore I can put in, for every 2 moles of water, I make 2 moles of sodium hydroxide. And now I'll go to my calculator. No, I won't. I think you can all do the math in your head. And both of these numbers are exact numbers. When you get the coefficients from a balanced chemical equation, they're always exact numbers. So I get 3.64 moles of water. And now it's time for step number 3. Moles of B, whatever we're trying to get to, water, to our actual answer, grams of water. And how do I know that? I can scroll up or look at my answer and notice question mark grams of water. That's what we're trying to find. And I just calculated, we have 3.64 grams of water. Yep, we got ahead of myself. 3.64 moles of water. And I want to get to grams of water. And you know what's coming. It's time to use unit analysis. Whatever we're trying to get to goes on top. I see a question, so time out for a question. And the answer to Gabriella is, of course, you got it? You're welcome. And as always, there's no such thing as a dumb question in my class. Remember, Dr. White has one of the fastest mouse wheel fingers either side of the Mississippi River. And back here, we're trying to get from moles of water to grams of water using your good buddy, your good friend. Whatever we're trying to get to goes on top. The units, whatever we're trying to get to goes underneath. And here we have moles water. Up here, I have grams of water. And where do we get that relationship? 1 mole of a compound equals its molecular weight of water, 2 hydrogen, 1 oxygen, 2 times 1.01. That's the atomic weight of hydrogen to 3 significant figures, 1 times 16.0, and you get 2.02, 16.0, add them up, 18.02, 2 past the decimal, 1. This should have 1 significant figure past the decimal. Keep the 0, use the 2 to round off, and therefore this number is 18.0. Notice they're both 3 significant figures. I got to get out of my 3 significant figure rut. So we take each of these numbers, which in this case, we're going to get the same answer. Doesn't always happen. And you round that off to 3 significant figures. So I'll give you 3 seconds to do that. Go. Time's up. And the answer is 65.5 grams. So you'd have to react 65.5 grams with sodium, and it'd be another calculation how much sodium, which we're not doing today, to make the amount of grams of sodium hydroxide. And that's how you do it. Remember, you can't go directly from, and students try to do this, and it's always wrong. Can't go from grams of this to grams of water. You can't. You need 3 steps. First steps, whatever we're given in grams, we convert to moles. Second step, whatever we have in moles, we convert to moles of the answer we're trying to get to. In this case, it's water. Where do we get that? From the balanced chemical equation. And this tells us 2 moles of sodium react with 2 moles of water to make 2 moles of sodium hydroxide and 1 mole of hydrogen. And that's where we got these 2 numbers. And finally, we've gotten moles of water, and we have to go step number 3, and you go moles of water to grams of water, which we've done today earlier and before, and use your good buddy, your good friend, do analysis. And with that, it's time for a 5-minute stretch break for Dr. White. In case you were wondering, last year I had some problems with my left thigh, my feet, and I went to physical therapy. And now I do religiously, after I sit down for a while, those stretches. And that's what I'm going to do. I'll see you at 11 o'clock. That's when the big hand is under 12. All right, let's get started, everyone. Ring, ring. Oh, wait, I can get you back. Time to go. Let's get going. All right, let's get going. Let's do another one of these problems, and I'm going to let you try it on your own. And the question is, how many grams of ammonia, NH3, are needed to make 2.101 times 10 to the third grams of hydrogen? Two things you'll need, which you can look up, but I'll give it to you. The atomic weight of nitrogen is 14.0, of hydrogen is 1.01. I'll give you a big hint. You need 3 steps. And let's just review those 3 steps again. Everybody see important mass calculations on your screen? Thank you. All right. Whatever you're given in grams, you convert to moles. Once you do that, the moles of what you now have, you convert to the moles of what your answer should be. And finally, you convert the moles of your answer of B, or what you're trying to get to grams. So grams to moles, then moles to moles, then moles to grams. And while you're doing that, I'm going to take a walk around the block. No, I won't. And the other thing I should remind you that's important is the balanced chemical equation there. While you're doing that, I'm just checking out in the real world what's happening. Ah. Remember, you need 3 steps. And by the way, if you ever have to leave early, life happens. Remember, you can always watch instant replay of Dr. White on my YouTube channel for Chem 1211. You know, that world famous YouTube channel where I'm a star, only in my mind. See everybody working hard as opposed to hardly working, which is a good thing. Just think, you had to pay to hear all my bad humor. Sometimes it's good humor too. Anybody remember the good humor trucks? You're doing some really serious chemistry now. Doesn't that feel good? It should. For those of you who finished early, please be patient. Try and give everybody time to finish. And if you finished early, you can always try this. This finger goes forward, this goes backwards. Do them at the same time, not the same direction, one forward, one backwards. When you master that, do it with your thumbs. I don't see anybody moving their fingers, so you must be working on the problems. I should mention, this is probably one of the longest problems you'll do this semester. There's another one coming up next chapter that's long too, and that's 15 points. But that's test number 3 stuff. Now that I scared you, I'm sorry. All right, I'll give you another 30 seconds and then I'll do it. All right, let's do this. Question is, how many grams of ammonia? So what are we trying to find? Grams of ammonia. What are we given? 2.101 times 10 to the third grams of hydrogen. And there's no way I can go from grams of hydrogen to grams of ammonia directly. And as I wrote, it takes 3 steps. And those 3 steps you can find when you're doing the test. Important information are step 1, mass of A, whatever you're given in grams, convert to moles. Then whatever you just calculated moles of, you convert to moles of your final answer. And now you convert moles of whatever you just got to grams of what you want, your final answer. So let's do this. Step 1. Grams of hydrogen, because that's the only number we have to work with. We want to go to moles of hydrogen. And this is the number I have. I want to get to moles of hydrogen. And it's time to use your good buddy, your good friend, unit analysis. Love that whistle. And I love unit analysis. Whatever we're trying to get to goes on top the units of the ratio. Whatever we're trying to get rid of units goes underneath. In this case, it's moles of hydrogen per grams of hydrogen gas. That's H2. That's important to remember. And where do I get that number? 1 mole of a compound equals its molecular weight. The molecular weight of H2, 2 times 1.01, that's the atomic weight of hydrogen, and that's 2.02. This is the exact number, so the answer here is 2.02. And now before I go to my calculator, do my units check out? Grams of hydrogen divided by grams of hydrogen. Remember, anything divided by itself equals the number 1, cancels out. So I'm left with moles of hydrogen, which is what I want. And now I'll go to my calculator. Let me empty it first. And now I'll take, in fact, what I might do is go to this one, because it's set up in scientific notation. And put the plus sign in there. And that's the number my calculator gives me. And now you round that off to 3 significant figures. And this is what I get. Forget about the zeros at the end. So we have 1.04 times 10 to the third moles of hydrogen gas. So let's go back to our problem. Now that was step 1. Step number 2 would be moles of A, in this case, A is hydrogen, to moles of B, what we're trying to get to. And if you look up here, that's moles of ammonia, because eventually we want to get the grams, but first we have to get moles of ammonia. So the only number I have to work with now is this number. And using your good buddy, your good friend, unit analysis, what units do I want to get to? And the answer is moles of ammonia. And now I know my good buddy, my good friend, unit analysis tells me whatever I'm trying to get to goes on top of this ratio. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? Where do I find a ratio of moles of ammonia, moles of hydrogen? For this problem, the balanced chemical equation. And notice the coefficients. For every 2 moles of ammonia, we make 1 mole of nitrogen and 3 moles of hydrogen. So for every 2 moles of ammonia, I make 3 moles of hydrogen. Again, for every 2 moles of ammonia, remember the coefficients are molar quantities, I make 3 moles of hydrogen. So now I can come back here and say for every 2 moles of ammonia, I make 3 moles of hydrogen. And if I move myself out of the way, you can see, do my units cancel out? Moles of hydrogen divided by moles of hydrogen. Anything divided by itself equals the number 1. So it cancels out. I'm left with moles of ammonia. Yay, remember ammonia, NH3. And I can now go calculate for step number 2, which I will. Now, helps if I remember what I'm supposed to do. Remember, 2 and 3 are exact numbers. And now for this one in column A, I'm going to round off at the end, but in column B, I'm going to round off at this step. And that should be 3 significant figures. So I'll make that 6.93 times 10 squared. And now let's go back to the problem. And the answer here would be 6.93 times 10 to the squared moles of ammonia. However, took the time up here, I want my answer to be grams of ammonia. So it's now time for step number 3. Whatever you have in moles, moles of B, in this case it's ammonia, we want to get to our answer, grams of ammonia. So how do I do that? Well, I have this. How many moles of ammonia? I want to get to grams of ammonia. So once again, I'll use my good buddy, my good friend. Anybody counting? I'm trying to get the Guinness Book of World Record of saying that phrase the most times in a semester in a chemistry class. I'll use my good buddy, my good friend, unit analysis, whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And this is grams of ammonia. This is moles of ammonia. And where do I get these numbers? 1 mole of ammonia or any compound equals its molecular weight. So now I have to figure out what's the molecular weight of ammonia. And I have 1 nitrogen and 3 hydrogen. Nitrogen to 3 significant figures has an atomic weight of 14.0. Hydrogen has an atomic weight of 1.01. Do the math, 14.0, 3.03. Add it up, 17.03. This has 1 past the decimal. This has 2, which is the lower number, times up. Hopefully I'll pick 1. And therefore I keep this one past this I used to round off. It's 4 or less. So for every 1 mole of ammonia, I have 17.0 grams of ammonia. Before I pick up my calculator, moles of ammonia divided by moles of ammonia. Anything divided by itself equals the number 1, cancels out. I'm left with grams of ammonia, and I'm time to go to my calculator. Oh my God, this doesn't this is rare. Must be time to go out and buy some lotto tickets. Not. But anyways, if you round both of these numbers off to 3 significant figures, this would be keep the 1, keep the 1, keep the 7, use the 8 to round off. That would be 1.18 times 10 to the 4th. Forget about the zeros. I have it set up in the spreadsheet. This one would be the same thing. 1.18 times 10 to the 4th. So come back here, and that'd be 1.18 times 10 to the 4th grams of ammonia. And that's the answer. And you'll see on an answer key when we do it on a test or on the problem set, in this case, it's the same answer both ways. And when you see that, that means whether you round off at the end or round off at each step, you get the same answer. And that's how you do this. And not this week, but next week, I have a problem set up for these type of problems for you to practice. And if you haven't figured out this morning, using classic Dr. White teaching, notice we started with the smaller steps, how to do this type of calculations of each of those 3 or 2 of the 3 steps. And then we put it all together. I did one and you had fun doing one. I hope you had fun. And when I've done these calculations where you do for both, I'm only asking you to do for one. Sometimes I've been doing it where you're dealing with about 250,000 pounds of chemicals, which is a lot of somebody else's money, and you don't ever want to make mistakes. I never have. All right, time to move on. And as you notice, for this 3-step, 1 mole of a compound equals its molecular weight, and the coefficients of the balanced chemical equation represent molar quantities. All right, let's talk about calculating the amount of substance taking place in a chemical reaction. And what this is really called is limiting reactants type situation. And reactants that is totally used up in a reaction, the other reactants are excess reactants. So let's consider the following. Where do I have one? All right. I don't know if, can everybody see the pen? I haven't done this in a while. Thumbs up, people. Can you see the pen? Now let's assume it's Dr. White's pen company, and I'm the president of a red pen company. And the way we do it is we buy the pen body, we buy the cap from different companies. And we have this in our inventory in our warehouse. And what I do in my company, I put the 2 together, make the whole pen set, and sell it to people and make a lot of money. What happens if I only have 5 of these and 10 of these caps in inventory? How many pen units can I make? The answer is 5, because I only have 5 of these. Even though I have 10 of these, I can only put 5 on here till I run out. Well, how do you do that in chemistry? Because at times you do run out. Now, time for a special gift from Dr. White. Instead of making you go from grams to moles and do everything in moles and then back to grams, I'm just going to keep it in moles. Shh, don't tell anybody I'm being nice, okay? But it still gives you the full intellectual thing. So let's take a look at a problem. how many moles of water are made, or I could say produced or synthesized. Now, I won't use that big word on you guys. Oh no, let me see if that's the President of the United States calling me. It's not. Two more rings and then you don't have to hear that sound. One more ring. Yes, I have a huge. Oh, they gave up. All right, let's get back to work. How many moles of water are made if you react 5.61 moles of hydrogen with 4.75 moles of O2? And how do you need this? You need 2 steps to do this. And good news, if you look at important information for test number 2, limiting reactants. I haven't done this in a while. Thumbs up, people. Do you see limiting reactants? Thank you. And how do you do this? You determine the number of moles of product produced using each reactant. And the lower number, and this is important, the lower number from these 2 calculations is the answer. So we have to determine the moles of product produced using the moles, and this is important, of each reactant. And that's where we get 2 steps. Because in my class, I'll have 2 reactants, so you need 2 equations. Let's look how you do that. Now, you want to do 2 steps. Now, for each one, you'll do the same calculation. Let me do something. And 2 steps or 2 calculations. And I'll take number 1. I'll say I want to go in both steps. You want to go to moles of reactant to moles of the product. So I have 5.61 moles of hydrogen. And I want to go to, first of all, I forgot to put down, shit, bad Dr. White. What are we trying to find? Moles of water. What are we given? 5.61 moles of hydrogen and 4.75 moles of oxygen. So for the first calculation, you want to go from moles of reactant, hydrogen, to moles of product, that's water. And you use your good buddy, your good friend, unit analysis, whatever I'm trying to get to goes on top, units, the other, whatever I'm trying to get rid of units, go underneath. And where do I get these numbers? From the balanced chemical equation. For every 2 moles of hydrogen, I make 2 moles of water. Remember, these are both exact numbers. And I'm going to do the math in my head for this one. And that's what you get. Now, for each reactant, you have to do this calculation, go from moles of a reactant to moles of product. Well, I did that for hydrogen, and now I'm going to do it for oxygen. And I have 4.75 moles of oxygen. I want to go to moles of the product. In this case, it's still water. And now I'll again use my good buddy, my good friend, unit analysis. Whatever I'm trying to get rid of or go to goes on top. Wherever I'm trying to get rid of goes underneath. I forgot to tell you this cancels out. I'll do it real quick. And now I'll write those. And where do I get the ratio of moles of water to moles of oxygen? I come up here to my balanced chemical equation. When there's no coefficient, it's the number one. 1 mole of oxygen makes 2 moles of water. 1 mole of oxygen makes 2 moles of water. So 1 mole of oxygen makes 2 moles of water. Remember, these are exact numbers. And now go to a calculator. And notice, oh, wow, 3 significant figures, 9.50. I'll come back here and I get 9.50. Now the question is, how many moles of water do you make? Well, I've got 2 numbers there, and let's go back to important information. And notice it says for limiting reactants, which one runs out first? The answer is the lower number. So I go back to my calculations, and which is the lower number? Either 5.61 or 9.50, time's up, and the lower number is this, and that's my answer. And it even says it on the screen. Oh, that's dad joke. And that's how you do this. You have to do 2 steps, and you calculate for each reactant, going from the moles of reactant to moles of product. And the important thing here is that the balanced chemical equation gives you molar ratios. In this case, 2 moles of hydrogen react with 1 mole of oxygen to make 2 moles of water. And that's where you can get the numbers you put here and here. And for this type of limiting reactants, the lower number of these 2 calculations is your answer. And that's how you do it. If I look at the clock, oh no, we're almost out of time. Time flies when you're having fun with moles and Dr. White. Remember, hand your lab in after Sunday. If you don't hand it in time, or within 48 hours, I will give you 0 points. Hand it in. Tomorrow, for Thursday's people, we'll go through chapter 6 and 7 practice problems. For the rest of you, Friday's lab will do the same thing. With that, I'll say enjoy the warm weather, even though it's cloudy out. Game gesund. Goodbye.